Vermiculite is a hydrous, silicate mineral that is classified as a phyllosilicate and that expands greatly when heated. Exfoliation occurs when the mineral is heated sufficiently, and the effect is routinely produced in commercial furnaces. Vermiculite is formed by weathering or hydrothermal alteration of biotite or phlogopite. Large commercial vermiculite mines currently exist in Russia, South Africa, China, and Brazil. Occurrence: vermiculite was first described in 1824 for an occurrence in Millbury, Massachusetts, USA. Its name is from Latin vermicula, to breed worms, for the manner in which it exfoliates when heated. It typically occurs as an alteration product at the contact between felsic and mafic or ultramafic rocks such as pyroxenites and dunites. It also occurs in carbonatates and metamorphosed magnesium-rich limestone. Associated mineral phases include corundum, apatite, serpentine and talc. It occurs interlaid with chlorite, biotite and phlogopite. Structure: vermiculite is a 2:1 clay, meaning it has 2 tetrahedral sheets for every 1 octahedral sheet. It is a limited expansion clay with a medium shrink-swell capacity. Vermiculite has a high cation exchange capacity at 100 to 150 meg/100 G. Vermiculite clays are weathered micas in which the potassium ions between the molecular sheets are replaced by magnesium and iron ions. Commercial uses: molded shapes. This process involves mixing exfoliated vermiculite with inorganic bonding agents such as sodium silicate and potassium to produce an earth-damp mixture. This material is then hydraulically pressed into shape in a mold, and then heat-cured at temperatures up to 180 degrees Celsius for up to 24 hours depending upon the thickness of the molded part. Such parts can withstand service temperatures of up to 1150 degrees Celsius and are often used in the aluminium smelting industry as backup insulation behind the carbon cathode in the potels which contain the molten mixture of cryolite and alumina. The molded shapes and boards are used in open fireplaces, high-temperature or refractory insulation, acoustic panels, fireproofing of structural steel and pipes. Calcium silicate boards. Exfoliated vermiculite is added to a calcium silicate slurry. This is then dewatered by pressing or by using one of the 4 Drinhatchk processes to form a flat board which is then heat-cured under pressure for periods up to 24 hours. Brake linings. Finer grades of exfoliated vermiculite are being used in brake linings primarily for the automotive market. The properties of vermiculite that make it an appropriate choice for use in brake linings include its thermal resistance, ease of addition to other raw materials to achieve a homogeneous mix and its shape and surface characteristics, roof and floor screeds and insulating concretes. Exfoliated vermiculite can be added at site to Portland cement and other aggregates, geological aids and water to produce roof and floor concrete screeds or lightweight concrete which have the benefit of being lightweight and insulating. In many cases vermiculite-based roof screeds are often used in conjunction with other insulation materials such as polystyrene board to form a total roofing system. A bituminous binder can also be used with exfoliated vermiculite can to produce a dry, lightweight roof screed which has the advantages of low thermal conductivity, low moisture content and ease of placement by pouring from the bag and then tamping. Soilless growing media. Exfoliated vermiculite is combined with other materials such as peat or composted pine bark compost to produce soilless growing media for the professional horticulturalist and for the home gardener. These mixes promote faster root growth and gives quick anchorage to young roots. The mixture helps retain air, plant food and moisture, releasing them as the plant requires them. These mixes were pioneered by Budley and Sheldrake. Seed germination, either used alone or mixed with soil or peat, vermiculite is used to germinate seeds. Very little watering is required. When vermiculite is used alone, seedlings should be fed with a weak fertilizer solution when the first true leaves appear. A tablespoon of soluble fertilizer per 1 imperial gallon of water is the recommended mix. Storing bulbs and root crops, pour vermiculite around bulbs placed in container. If clumps are dug, allow to dry for a few hours in the sun and then place in cartons or bushel baskets and cover with vermiculite. The absorptive power of vermiculite acts as a regulator that prevents mildew and moisture fluctuation during the storage period. It will not absorb moisture from the inside of stored tubers, but it does take up free water from the outside, preventing storage rot. As a soil conditioner, where the native soil is heavy or sticky, gentle mixing of vermiculite up to 1/2 the volume of the soil is recommended. This creates air channels and allows the soil mix to breathe. Mixing vermiculite in flower and vegetable gardens or in potted plants will provide the necessary air to maintain vigorous plant growth. Where soils are sandy, mixing of vermiculite into the soil will allow the soil to hold water and air needed for growth. As loose fill insulation, exfoliated vermiculite treated with a water repellent is used to fill the pores and cavities of masonry construction and hollow blockwork to enhance fire ratings, insulation and acoustic performance. Coarse grades of exfoliated vermiculite can be used to insulate lofts and attics. Exfoliated vermiculite has the benefit of being easy to use with application consisting of pouring the vermiculite between the joists and then leveling, refractory insulation gunning and castable mixes. Exfoliated vermiculite can be combined with high alumina cements and other aggregates such as expanded shale, clay and slate to produce refractory insulation concretes and mortars. In the early days of their uses these products were batched at or very close to the place of installation. This continues to be the case in some limited circumstances, however more and more use is being made of pre-batched proprietary mixes. Mixes containing vermiculite are used in areas where strength and corrosion abrasion resistance are of secondary importance, the most important factor being the insulation performance of the in-place refractory lining. These mixes find their uses in such areas in industries including iron steel, cement and hydrocarbon processing. As a constituent of a coating, vermiculite dispersions are typically either chemically or physically very finely delaminated vermiculite in a fluid medium. These dispersions can be used to make vermiculite paper sheet by simply pouring them onto a piece of smooth low-surface energy plastic and allowing to dry. The resulting sheet can then be peeled off the plastic. Typical end uses for vermiculite dispersions include in high-temperature coatings or binders for construction materials, gaskets, specialty papers, textiles, oxidation-resistant coating on carbon-based composites, and as barrier coatings for films. As a packing material, valued for its high absorbency, waste treatment, the cation exchange capacity of vermiculite allows it to be used in fluid purification processes for wastewater, chemical processing and the pollution control of air in mines and gases in industrial processes. In addition to its ion exchange properties, exfoliated vermiculite will retain liquids within the interlaminar voids of the individual particles as well as between the particles themselves. As a substrate for various animals and/or incubation of eggs, as a lightweight aggregate for plaster, proprietary concrete compounds, fire-stop mortar and cementitious spray fireproofing, exfoliated vermiculite is used in both hand and spray-applied general building plasters to improve coverage, ease of handling, adhesion to a wide variety of substrates, fire resistance, and resistance to chipping shrinkage. As an additive to fireproof wallboard, as a component of the interior fill for fire-stop pillows, along with graphite, as a carrier for dry handling and slow release of agricultural chemicals, as a growing medium for hydroponics. As a hot topping, both exfoliated and crude vermiculite have been used for hot topping in the steel industry. When poured onto molten metal, crude vermiculite exfoliates immediately and forms an insulating layer, allowing the material to be transported to the next production process without losing too much heat. Used to permit slow cooling of hot pieces in glass blowing, lampwork, steelwork, and glass bead making, used in and ground swimming pools to provide a smooth pool base. Finer grades of exfoliated vermiculite plus Portland cement may be combined either on-site or a factory premix to provide a base for swimming pool vinyl liners. These mixes are either pumped into place using a rotostator pump or hand-poured. Used in commercial hand warmers, used as a sterile medium for the incubation of reptile eggs, lightweight insulative concrete, used in AGA cookers as insulation, used in explosive storage as a blast mitigant, used to absorb hazardous liquids for solid disposal, used in gas fireplaces to simulate embers, used as part of a substrate for fungi cultivation, commercial manufacture of exfoliated vermiculite. In 2005, South Africa was the top producer of vermiculite with about 40% world share, followed by the USA and China, reports the British Geological Survey. While some exfoliators focus on only a few of the possible applications, others can provide vermiculite products for all its applications. It is common for vermiculite exfoliators to exfoliate perlite also, as both are often sold together. For those who want to set up a new exfoliation process, it is possible to find expert consultants to advise in the design and construction of the desired facilities. Vermiculite exfoliators have an international trade association called the Vermiculite Association to represent the industry's interests and to exchange information. Many of its members also maintain memberships in the Perlite Institute. Fireproofing. While spray-applied asbestos-containing fireproofing and girder insulation is still widely found in old construction, in some parts of the world it is still being used. Recent improvements of these sprays replace asbestos with aggregates of MMF including rockwool and ceramic fibers. The cementitious versions of these fireproofing sprays contain Portland cement and lightweight aggregates of the plaster vermiculite. Vermiculite ore, particularly that ore extracted from the Libby mine in Libby, Montana, USA, may contain asbestos. The US EPA advises that vermiculite from the Libby mine should be considered to be contaminated with asbestos. Since the Libby mine has been closed since 1990, currently produced ores are considered safer because they have lower asbestos content. Danger of exposure to asbestos in these spray-applied materials is greatly increased by not following proper industrial hygiene procedures and by not following abatement regulations. Asbestos contamination. Although not all vermiculite contains asbestos, some products were made with vermiculite that contained asbestos until the early 1990s. Vermiculite mines throughout the world are now regularly tested for it and are supposed to sell products that contain no asbestos. The former vermiculite mine in Libby, Montana, did have tremolite asbestos as well as winkite and richterite. In fact, it was formed underground through essentially the same geologic processes as the contaminants. Pure vermiculite does not contain asbestos and is non-toxic. Impure vermiculite may contain, apart from asbestos, also minor diopside or remnants of the precursor minerals biotite or phlogopite. Controversy over health risks. The largest and oldest vermiculite mine in the United States was started in the 1920s, at Libby, Montana, and the vermiculite was sold under the commercial name Zonolite. The Zonolite brand and the mine was acquired by the W.R. Grace Company in 1963. Mining operations at the Libby site stopped in 1990 in response to asbestos contamination. While in operation, the Libby mine may have produced 80% of the world's supply of vermiculite. The United States government estimates that vermiculite was used in more than 35 million homes, but does not recommend its removal. Nevertheless, homes or structures containing vermiculite or vermiculite insulation dating from before the mid-1990s are and especially those known to contain the Zonolite brand may contain asbestos, and therefore may be a health concern. An article published in the Salt Lake Tribune on December 3, 2006, reported that vermiculite and Zonolite had been found to contain asbestos, which had led to cancers such as those found in asbestos-related cases. The article stated that there had been a cover-up by W.R. Grace Company and others regarding the health risks associated with vermiculite and that several sites in the Salt Lake Valley had been remediated by the EPA when they were shown to be contaminated with asbestos. W.R. Grace Company has vigorously denied these charges. The vermiculite deposit at the mine in Libby, Montana, was heavily contaminated with asbestos. Numerous people were knowingly exposed to the harmful dust of vermiculite that contained asbestos. Unfortunately, the mine had been operating since the 1920s, and environmental and industrial controls were virtually non-existent until the mine was purchased by the W.R. Grace Company in 1963. Yet, knowing the human health risks, the mining company still continued to operate there until 1990. Consequently, many of the former miners and residents of Libby have been affected and continue to suffer health problems. Over 400 people in the town have died from asbestos-related disease due to contamination from vermiculite mining from nearby Zonolite Mountain, where soil samples were found to be loaded with fibrous tremolite, and countless others there who insulated their homes with zonolite have succumbed to asbestos-related diseases, most of whom never were employed in environments where asbestos was an issue. After a 1999 Seattle Post-Intelligencer story claimed that asbestos-related disease was common in the town, the EPA, in response to political pressure, made cleanup of the site a priority and called Libby the worst case of community-wide exposure to a toxic substance in U.S. history. The EPA has spent $120 million in Superfund money on cleanup. In October 2006, W.R. Gray's company tried to appeal the fines levied on them from the EPA, but the Supreme Court rejected the appeal. The United States government is also pursuing criminal charges against several former executives and managers of the mine for allegedly disregarding and covering up health risks to employees. They are also accused of obstructing the government's cleanup efforts and wire fraud. To date, according to the indictment, approximately 1,200 residents of the Libby area have been identified as suffering from some kind of asbestos-related abnormality. Jury selection was to have been completed in February 2009. The case ended in acquittals on May 8, 2009. On June 17, 2009, the EPA issued a public health emergency in and near Libby, thereby allowing federal agencies to provide funding for healthcare, and for removal of contaminated insulation from affected homes. See also, passive fire protection, fireproofing, fire stop, asbestos, perlite, sodium silicate, plaster, list of minerals, square foot gardening, references. External links, the Vermiculite Association, Cornell Budley and Sheldrick, 1, U.S. Geological Survey Vermiculite Section, Environmental Working Group, United States Environmental Protection Agency, the Perlite Association, 2, Petition for Writ of Certiorari to U.S. Supreme Court, U.S. EPA, Additional frequent questions on vermiculite, promote high-temperature insulation.